So, I'll say it again. This lesson we're going to have a quick little tutorial on how to insert graphs, how to change graphs, and there might even be some coding. Now, I'm not going to say what the independent variable is, what the dependent. It could be changing distance, measuring time. It could be changing length, measuring force. In science, you change one thing, you measure another. Okay? So imagine we set up an experiment where we're going to change something by a constant step. Now, normally you go 1, 2, 0, 2, 4, 6, 8. It's going to take a while. And I think I've shown you this before, that Excel has pattern recognition. You don't have to type in 100 lines. It recognises that you're going up by 2. So highlight those 3 values, and if you move your cursor to the bottom right, you'll notice that the cursor changes to a black cross, from a white cross to a black cross. You're going to click and drag that down, and let's drag that down to about 20. Okay? So let's just imagine that we were really, really thorough with our experiment, and we took 18 different trials, and each time we changed our independent by 2. It could be 2 centimetres, it could be 2 kilograms, it could be 2 grams of hydrochloric acid, whatever. We don't care, all right? We're just worrying about the numbers. Now, I'm going to just make up some numbers out of the top of my head. So, okay, we can't really use the pattern recognition for the next column. Imagine now I took my measurements during the experiment and I'm writing them down. Okay, so I'm going to write these down, and I'd like you to follow with me as well. And I'm just making these up. Oops, sorry, I'll leave that there for you to copy them down. Yep. I know. Just copy it all down. Just follow my madness. All right, so write all those numbers down, please. And I will zoom out so that now we can see them all. I've still got more. Let's keep making some more numbers. Okay. There's all our numbers. So please get them written down nice and quickly. Now, what Excel likes to do, when we highlight these rows, Excel is going to say, well, I think the first row, this person has placed his independent variable. So we're going to place that along the x-axis. And then it goes, I think the second column, I should have said column, the second column, that might be what he's measured. That's his dependent. And we want to put that on the y-axis. So let's see if it does this. I want you to highlight just the numbers. And we're going to go up to Insert. Now for me, the charts, you're going to go Insert Charts, and you want a scatter like so. Okay? So yours, if you're on a Mac, it might the toolbar might look different, but you go Insert, Charts, you're going to go into the scatter, and I've just picked a scatter with smooth line and markers. Okay? Smooth line and markers. And let's just double check. Our independent goes up to 36. Yep, so it's put our independent variable on the x-axis, and it's put our dependent on the y-axis. Okay? Now, this looks quite nice, but we took our dependent variable, we measured in the lab with measuring devices, and we might have made an error. Okay, we might have mistakenly written down the wrong number. Someone might have mistakenly shouted out 35 when they meant 25 because they had the ruler upside down. Maybe they teared the scales. Maybe the spring scale was broken. There's sources of error. Who can, hand up, who can see there might be one source of error in this experiment? Yes, William?
You got that up there.
The bump there. Give me the values corresponding to that bump. Can you see where it is in the table?
33.
33. Yeah, maybe it should have been 23. Maybe we got the wrong number. So I'm going to, looking at this, I'm pretty confident that there's a pattern between what we changed and what we measured. And I'm going to exclude that dot point. We're going to call it an outlier. Okay? Now all I need to do, now we could go in here and delete, well, we're not going to delete the series. I'm going to find it over here and I'm just going to remove it. Okay? Now, because I've deleted it, it's put a big blank space there. It's got an empty cell now. And it's thinking, oh, maybe he's going to write something else in, and I don't know yet. But let's just get rid of it altogether. If I delete the 12, I'm fairly certain... No, it doesn't join it with a line. Okay. What we're now going to have to do, because I might want to keep my line there, I'm going to take my data, okay, I'm going to place the cursor near the top. See how it changes it to that sort of XY axis with the little arrows? See how the symbol changes? I'm going to click and I'm going to drag it up and see how it's joined my lines. There's one other option. I can Control Z that. We could also just go up to the row 8 and go right click, delete, and it does the same thing. It just chops out that empty row and it takes our data and it puts it back together nice and neat so there's no gaps. Okay? Now, boys, I'm not suggesting that you have to be always trying to delete data, but if there is one that just seems to be way out there, you might want to ignore it. Okay? But again, don't go trying to cull every second one that doesn't appear. You know, this one here for 26 looks a little bit low, but I'm not going to delete it. Okay? Just the one that might look crazy. And you might not ever have that. Your experiments might go all perfectly. If you take your measurements accurately and there's no mucking about and there's no errors, you might not even get it. Okay? Now, next thing. With the new Office, there's a little plus arrow here. Do you all have that plus arrow?
No.
You're in Mac. So what you'll need to do is go up to Quick Layout. Now, I don't know how to go to Quick Layout from here. Design. You can go to Quick Layout because our graph is missing things. It's missing a labelled axis. Okay, we've got to put labels down. So what I would suggest, we're going to find one of these quick layouts that has what we require. Number 1 or number 9 seem to be nice. Now, layout 10. So I'm just going to go layout 10. Okay. Oh, now we're missing the title. Hang on. Number 1. There we go. We've got title. And now, this is where you would name your axes, including the measurements. So this would be independent brackets units. Okay, so it could be distance bracket meters. Or it could be time bracket seconds. Whatever your measurement is. Okay? So let's go. Let's say that it's time in seconds. And then let's go up here and I'm just going to say, all right, let's imagine that this was distance bracket meters. Okay. And now your title has to relate what we changed compared to what we measure. Okay, and you've been doing this all the way through science. In all of your tests, you've got to make sure your title relates what we changed to what we measured. So this could be Okay, I'm just making this up as I go along. I've decided that maybe we recorded, every second we recorded where the person was. Okay, so we change time, we measure distance. That's it. Time's an easy thing to change. It's always changing. We can't stop it. It's always going on. And if we have a stopwatch next to us, boom, we're changing time and we measure something else against that. Okay? Now, let's just take this experiment one step further because we're all here now. Let's suppose we said, right, maybe we're going to have 2 people running. Okay? So, at the moment we've got series 1. Now, normally I would delete that series over on the right. I'd go there and delete that because we don't need a key when you've only got one thing on the graph. Let's go one step further and let's place 2 series on this graph. So let's call this dependent number 2. Okay? So imagine we said we're going to take another person. We're going to do exactly the same experiment. We're going to use the same independent variable. We're going to measure this person's distance every 2 seconds to see if their distance is changing. So just copy these numbers down. And again, I'm just going to make them up. Okay? So just copy these down. All right, copy those numbers down for me. While you're doing that, I'm just going to change this because I've just decided that this is going to be a time and distance. You don't need to worry about changing the... Okay. Now, what you are going to do now is you're going to right-click on your graph and you're going to go down to Select Data. So Control-click, Command-click, right-click, whatever, go Select Data. And now you've got your Select Data options. Over here we've got our entries. What are we using? Now, at the moment we've got Series 1. Now I'm going to edit that and it brings up your edit box and I'm just going to change it. Don't call it Series 1, let's call it Runner 1. And you'll notice on the graph, it's changed it. It's no longer called Series 1, it's called Runner 1. Now, if this was Jonathan, we could write Jonathan. If this was Gregory, we could write Gregory. Let's just call it Runner 1. Now, we are going to add another series. So I'm going to click Add. And it's going to bring up another edit box. And let's call it Runner 2. You'll notice now it's making a key for us. It's just defaulted to orange. We're going to have a blue line graph and an orange line graph. Now we need to tell Excel where are we looking for the X values. Now the X value is the time. We're sharing that it's the same time. It's the same independent. So you're going to click Select and you're going to highlight your time values. And then press Enter. Or click that box. And then it says, well, what about Y values? Where am I dependent? What did I measure? Oh, I measured this one. So I'm going to highlight distance 2. And press Enter. Okay? So if you ever get stuck, you just right-click on your graph, go Select Data, and you can add or edit. Now, I didn't save that, so I'm going to have to do it again. Let's go Add. We're going to call him Runner 2. The Y values is the distance 2. X values is time in seconds, and the Y value I decided was distance in meters. Okay, and for some reason it lost that runner at 1. Go OK, go OK. Now, same deal. I think someone's made a bit of an error here. Okay, I don't think it's possible in 2 seconds that a person managed to travel 20 metres. That's them travelling about 40 kilometres an hour if they're jogging, which isn't really possible. So, can anyone spot the outlier? Yes, one person. Everyone should. Guys, look at the board. This one. Yeah? Let's get rid of it. It's that massive distance at 28 seconds. It was 68. Let's get rid of it. We can just backspace it now. Now, there's an issue. I can't just delete this row. If I deleted the 28-second row, I'm also going to delete the blue dot. And we don't want to delete the blue dot. The blue dot's happy. It's good. It's part of its series. So I reckon we should grab... well, actually, I think we might just have to leave it because he's being shared. Okay? You could do an average, but then that's not taking data in the experiment. That's just sort of guessing. And we just want this to be recorded data. So I think we'll leave that blank for now. Okay? Now, I'm just going to bring this graph down and make him a little bit larger. And get rid of him. There's one last thing that we might want to do at this point in time, and that's to put a trend line. Now, it does look pretty linear. It looks like a straight line. You're only going to put in a trend line if you think the data is linear. If it looks curvy, if it looks like x squared or square root or 1 on x, some other kind of maths function, you're not going to put a trend line. Okay? So, what I would like you to do, right-click on the data. So click on any one of the dots, and you should have this option. You're going to go down to Add Trend Line. Okay? Now I right-clicked on the orange data, runner number 2, so it's placing a trend line for runner number 2. Okay, and we've got all these options down here. We can set the intercept to 1, or we can just remove it. We can put an equation on the chart. Now the equation, you're going to worry about equations when you get to year 9 and year 10. That's the equation of that line. We could place it there. We can even move that trend line forward or backwards. If we bring it forward, say, 10 seconds, we can try and predict where he might be. We could extrapolate the data using a line of best fit. Okay? But for now, we don't really want to extend it. Let's just leave it like that. I'm going to right-click on the blue data and go Add Trend Line again. Okay, and there's the blue data. Now the blue data looks a little bit nicer. Let's add an equation on his charts. And if we could also set the intercept as well. Okay, now it's getting a little bit jam-packed there. We've got 2 different series, and each series has their own line of best fit. So it's getting a little bit tricky down there. Okay. And so it's up to you, depending on if you had 5 series, you're not going to have 5 series and 5 trend lines because it's going to just be getting crazy. Okay. But you've got all of these options, and with me using Windows, there's an arrow over here that you can edit things. The easiest thing to do is just to right-click on click on the trend line, and you're going to get all of your options coming up here. You can move things around, so you can move your key out of the way. You've got all of these options to you can make your graph larger and have the key out of the way over here. And you can do all of the usual things like changing the colour, changing the background, changing how many axes you have. But boys, remember, from the past couple of years, remember your marks for the graph. It's got to be neat. It's got to have a key, constant scale step. It's got to be easy to interpret. Imagine you gave this graph to somebody and they can read the information off it. Okay? If there's too much stuff going on, if it's too difficult and squished and there's too many things, it's not going to be difficult to interpret. Okay? So with a lab report, with the diagrams, with the method, with the graph, imagine even with the table, ask yourself, if I gave this to somebody, if you printed this off at the library right now and gave this to someone, would they be able to figure out what you're showing? And I would say yes. If this is the distance versus time of a runner, and at 0 seconds they were both at 0 metres, and it looks like runner number 1 seems to be travelling further for every second because he's got a higher value. Okay? Something, and if they say, oh, maybe there was no recording at the 26-second mark for the runner number 2, and there doesn't seem to be any recording for the 12-second mark either. Okay? But that looks nice and easy. And you could even see who won. So you could tell that runner number 1 was running faster. Okay? Because they're covering more distance for every change of time. Okay? So, gentlemen, I've given you this lesson because we're about to do another investigation, and I would encourage you to use Excel to produce your graph. Okay? And then you can plot it, display it nice and neatly. You can copy this. All you need to do now, if you right-click and go copy, you could paste that into Word. Okay? I don't really know what's in Word right now, but I could just go open blank document, graph, Control V, boom, done. Next, what's next? Discussion. Okay? And it copies everything across. It's like you're looking right at the Excel screen, and everything's been brought across. Okay? But we'll kill that for now. We don't wish to save. So I'll upload this to YouTube, and if you're ever stuck, you can go back there. And we'll say goodbye to YouTube people now.